All right, let's get right into it. Right now, our solar system has a visitor, an object from the dark, cold space between stars, and its name is 3I/Atlas. But this is no ordinary cosmic tourist. The more we look at it, the weirder it gets, and it's starting to challenge everything we thought we knew about visitors from other star systems. It's sparked a huge scientific debate, and it is a fascinating story. And this quote? It really hits the nail on the head. This thing is so strange that it's got everyone talking. Not just astronomers, but, well, everybody. Is it just some new kind of natural wonder? Or could it be something entirely else entirely? In this explainer, we're going to unpack the clues in what's become a real-life cosmic detective story. So first things first, what is this thing we're talking about? Officially, 3I/Atlas is only the third confirmed interstellar object, or ISO, that we've ever seen. Now, you might remember its predecessors, the really bizarre cigar-shaped Oumuamua back in 2017, and then the more normal comet-like Borisov in 2019. Each one of these visitors is an absolutely precious, fleeting chance to see the building blocks of other solar systems. And the implications of that are just huge. I mean, think about it for a second. These ISOs are actual physical samples from star systems light years away, delivered right to our cosmic doorstep. Studying them, what they're made of, how they move, it's pretty much our only way to directly analyze stuff that formed around another star. It gives us these priceless clues about how planets might be forming all across our galaxy. Because this thing is just passing through, the entire scientific community basically scrambled to get a look at it. This wasn't just one telescope. This was a real all-hands-on-deck moment. From the moment it was discovered in July, we've pointed everything at it. Orbiters around Mars, the Hubble Space Telescope, the James Webb Space Telescope, you name it. We've thrown our absolute best technology at this thing to grab every last bit of data before it disappears back into the void forever. Okay, and this is where our detective story really kicks into high gear, because the plot is about to thicken big time. As all that data started pouring in, it became obvious pretty fast that 3I/Atlas wasn't, playing by the rules. It just refused to fit neatly into the box of, oh, it's just another interstellar comet. Let's open up the evidence file. First off, the gas it's giving off, it's weird. It's almost all carbon dioxide, not the water vapor we'd expect from a comet. Then, it's showing signs of ionized nickel, which is a big deal. The way it scatters sunlight is unlike any comet or asteroid we have ever seen. And here's the kicker. It's accelerating. It's getting a tiny push from something other than the sun's gravity. And all these clues point to one very strange path through space. So look, while all those other clues are super interesting, its path, its trajectory, that's the real smoking gun in this whole mystery. That tiny, non-gravitational push it's getting isn't random. It actually seems to be steering the object toward a very specific destination, right here in our own solar system. And this number just says it all. The chance of a normal, natural comet just randomly venting gas, happening to align its path so perfectly that it flies right through Jupiter's Hill sphere, which is basically its immediate zone of gravitational control, the odds of that happening by chance are just 1 in 25,000. That is a staggeringly unlikely coincidence. So you take that crazy trajectory, you add in all the other weird physical clues, and you're forced to ask a really big question. What are we actually looking at here? The simple, easy answers just are not cutting it. Well, when faced with a mystery like this, the scientific community has come up with 3 main competing theories to try and explain what's going on. You can kind of think of them as the main suspects in our investigation, and each one is trying to account for all those bizarre clues we've been gathering. Let's compare them side by side. You can see right away that the traditional comet model really struggles. It's just not consistent with the object's apparently high density, its weird gas composition, or that ridiculously precise trajectory. Now, on the other end, the technological artifact model explains the trajectory as, an intentional engine burn. But wow, that is a huge leap to make. But look there, in the middle column. This new idea, the crustal fossil model, it actually seems to line up pretty well with a high-density structure, a mineralized surface that could explain the strange light reflection, and a way to release gas that fits the data. And this brings us right to the great debate itself, where scientists are weighing all this evidence. And honestly, this is a perfect example of science in action. You get extraordinary data, which leads to these competing ideas, and then those ideas get rigorously challenged and tested by the entire community. It's messy, but it's how we find the truth. The argument for the artifact theory is, well, it's direct and it's powerful. The people who support it are basically saying that a 1 in 25,000 coincidence isn't a coincidence at all. They argue the trajectory is so precise because it's a deliberate maneuver, maybe to use Jupiter's gravity to park probes or something. But, and this is a big but, here comes the pushback. As astronomer Samantha Lawler says, the bar for a claim like alien technology is unbelievably high. And while the data we have is certainly weird, it is not yet that kind of slam dunk, extraordinary proof you'd need to completely upend what we know about the universe. So really, the whole debate boils down to this. You have a mind-boggling statistical improbability on one side and cautious scientific skepticism on the other. Is that trajectory a deliberate signal, or are we just seeing the normal, but to us, weird, behavior of an object from a completely different solar system? I mean, think about it. Our sample size is just 3 of these things. How do we even know what's normal? And this is exactly why that third theory has become so important. It offers a potential path right down the middle, a natural explanation that's still exotic and new, but doesn't require us to imagine alien engineers. It suggests we aren't looking at a comet at all, but something much, much older and more solid. So the idea behind the Interstellar Crustal Fossil is that 3I Atlas is a solid chunk of rock, a piece of the crust that was ripped off an ancient planet or moon. Now, this would explain why it's so dense and strong. The gas we see wouldn't be from ice turning into vapor, but from small, trapped pockets of gas venting out through a solid, rocky surface. It's a really clever way to explain the data without having to rewrite physics. So where do we go from here? What's the next step? Well, this cosmic case is far, far from closed. In fact, some of the most critical moments for gathering new evidence are actually still ahead of us. The object will get closest to the sun in late October and then make its closest pass by Earth in December. But the date that everybody is circling on their calendars is March 16th, 2026. That is when it reaches Jupiter. How it behaves during that flyby is going to be a massive, massive test for all 3 of these competing theories. To finally crack this case, scientists are focusing on 2 key measurements. First, they need to get a super precise reading of something called the deuterium to hydrogen ratio in its gas. Think of it like a chemical fingerprint that can tell us where and how it formed. Second, and this is probably the most important, is tracking that mysterious push. If the acceleration is all wobbly and variable, that points to messy, natural outgassing from a spinning rock. But if that push stays constant and focused, well, that would be a whole lot harder to explain away. And that's really why this matters so much. This strange visitor is way more than just an astronomical curiosity. It is forcing us to confront our own assumptions, to come up with brand new theories, and it's a perfect real-time demonstration of how science actually works when it's faced with a true, genuine unknown. So we're left with this incredible, tantalizing question. Is 3I/Atlas an ancient piece of a lost alien world? Is it a technological messenger sent on a specific course? Or is it simply a powerful reminder that the universe is and always will be far stranger and more wonderful than we have yet imagined? The investigation continues, and for now, the verdict is still out there.